Tech Talk Tuesday. Hey, Charlie. Hey, Chuck. Hey, man, I appreciate you guys checking in. Tech Talk number 121. We got some good stuff to talk about today. I know I say that every week, but I think this is number 121. Look, you guys, thank y'all so much for coming in. Alan, Chris, Alex. Hi, y'all. Good to have some names on here, some friendly folks, people that are glad to see me. I'm glad to see y'all. I was going to tell you, man, Brian and Chuck, hi, y'all. Joe, I raced all these years. Brian, good to see your name, man. Tell the girls I said hi. Hines. Man, look at these cool names. Sam, yep, ready. Yeah, Sam, I learned a lot from you too, brother. Hey, Bruce. Hey, we'll talk just a quick minute. I'll just run my mouth. Hey, Ed, Greg, great to see these names. Brad, thank you for checking in, Brad. What a great weekend you had, learning all that stuff all over again and starting from scratch on some stuff. Man, I kind of watched best I could. I was telling my buddy Mitch Brown that weather at the race was hard enough to, hey, Ronnie, hey, Brian, the weather was hard enough to get you tired. I mean, all you had to do was stand outside and work on your motorcycle for 2 or 3 days, and by the end of Sunday, man, you just whooped and tired from all the weather, too. Never mind all the people going on there. Hey, first time, Jimmy, good. I tell you, if you're watching John Boy and Billy, or you look at that in the morning and you say, first time caller, they go, they make a big cow noise. Isn't that funny? Hey, Donald, Daryl, Ron. Hey, Ron Smith, Claude, and Stephen. Yep, look, thank you all so much. This is a beautiful thing to do. Tech Talk Tuesday, 121 weeks in a row. Great to see all you guys signed up on here. Hey, big Ronnie and Raymond agent. Yep, God bless you, man. Reggie, long time. Bruno, Stevie. What's some great names? Sooner or later, I have to get off of calling everybody's name out and start talking about the meat and potatoes of my show here. I can't just call your names, but I do really appreciate you guys. Mike, Greg Turk, we're learning. I had some feedback this week that I want to share with you guys. I had a guy that said, I started watching Tech Talk, so I went back to the beginning and started watching all of them, and he started at lesson number 1, which was 121 weeks ago, and now he's slowly but surely working his way up through the years, and I know this is, a 121 doesn't sound like much, but, you know, that's like, I know, wow, time really flies. You're right, man, Charles. Raymond, look, I'm just going to tell you, man, this is crazy. I haven't done anything 121 weeks in a row I can think of. I mean, I've never even, 67 years old, and when I started Tech Talk, I kind of set a precedent that I was going to do this every Tuesday at 6 o'clock Eastern and talk about things I think I know about and that I'm passionate about. And now it's 121 weeks later, and some of the episodes have been great. Some have been awesome. Some have been not so great. But, man, I tried to hit it even when I was sick, even when I was well, even when I was flying, or even when I was driving. I tried my best. So I'm going to I know how hard it is to do anything 121 times in a row. But let's get into, hey, Josh. Hey, Ed, Bruce. I just want to share a little something with you guys. I want to tell you that this week, I think Friday, what is that? Today's Tuesday, Thursday, Wednesday, Thursday. Friday will be 42 years that Jackie and I have been running and working and hammering away at Star Racing. That's a 42-year anniversary for us, Thanksgiving weekend. And, boy, you talking about thankful? Thanksgiving is about being thankful. And I'm going to tell you, man, that is unbelievable. I retired from working in the shop. I retired from working on engines for people and trying to turn over a lot of money a year just to make payments and just to make payroll and just to pay the bills, and ended up that I feel your struggle, brother. Any of you guys that are running a business, a small business or a large business where you have to make a certain amount of money every week or every month in order just to keep the lights on. And boy, what a crazy time we're going through now. So I'm preaching to the choir right now, telling all you guys this. But I wanted to tell you that Jackie and I started when we were kids, I think. But we opened Star Racing Thanksgiving of 1979. And this will be Thanksgiving of 2021. So I think that comes up to be about 42 years. My math is questionable, just like my spelling. But let's get into the hot rod parts. A few things. I'm going to flip the camera around to share with you guys. Let's see if I can make this happen better. There we go. Thank you guys. There you are. Hey, Jim Bob and David, Ronnie. This right here looks better than me. This is a really cool Milwaukee 8 piston. And I know the words are backwards, but what it says is, what I learned in engine building all these years is, just because you can doesn't mean you should. See how backwards that is? But what it says, just because you can doesn't mean you should. Just because you can make a really big piston fit in an engine doesn't mean you should. But I got some guys send me some pictures on email and send me some message and stuff, and they ask me a lot of technical questions. And I'm technical by passion. I'm technical by the good Lord bless me with 40 or 50 years to study this kind of stuff and pay for what went wrong. And hey, thank you all for the Jack Dallas. Thank you all so much, Brian. There's the legend. Oh, wow. So anyway, yes, I'm the old version of me. Some of you saw me and learned and taught and met me when I was really young, and that was the younger version of me. Also, I wasn't even the greatest guy in the whole world, and I made a lot of mistakes, and I treated a lot of people wrong. And I want to tell you that that's the old guy. He's gone. I'm the new guy, and I'm going to try my best to be a better guy and tell y'all what I think I know and share the truth with you and give the good Lord the glory for all I've learned and lived through. And it's been a lot, and I would never have a contest with anybody watching or anybody that you talk to about who's had a tough time or a good time, but I had a great time, and I have enjoyed my career, and I learned a lot about this stuff, and I want to share some of it with you. But I got some pictures this week from a customer client that showed me where his pistons, let's see if I can get this still enough to show you. The top land right here was burnt. The top ring was burnt. Let's get this thing really focused up nice. And the second ring was really burnt. I'll draw a picture on the board to help you understand exactly what I'm trying to say. But when you got the ring goes here, and the land above the ring, let's try and get this picture just right. This land here above the ring is burnt, and the land below the ring is burnt. That means that this ring right here was going through Hades in its lifetime. It hates where it was. It hates the heat, because this piston in reality is the hottest thing. It gets all the heat put into it. It gets 600, 700, 800 degrees of temperature, enough to melt one of these. And the ring is the only thing that's supposed to touch the cylinder wall. And that ring takes all the heat out of this crown and puts the heat into this ring, and then that ring transfers the heat to the cylinder wall. And if you have a car, V8, it's got water jackets outside the cylinders, or the motorcycle has fins, and some engines are oil cooled, water cooled, air cooled, and there's lots of different coolant there. Hey, Kevin. And when this ring burns up and the land above it and the land below burns up, and I'll show you some examples of what I'm talking about, that means that there's too much heat in here. And that means that the big pressure is happening at the wrong time, or the mixture is wrong. So if we're running lean, we're going to get some heat in here. If we're running the ignition timing, we're starting it too soon, which I'll show you what that's about, you'll have too much heat in here. So we want the cylinder pressure to happen at the right time, so that the pressure will push the piston down, therefore turn the crankshaft. And I'll talk about that a little more. But I wanted to tell you about, there's several things that a ring lives through. And since I got to see you guys in person, now I'm going to go and take this and flip it over to the board so I can draw a couple pictures for you. I'm going to try. Okay, let's get in here and sketch a minute. I know that makes a terrible noise when I move that phone around. All right, now that it's not shaking as much on me. Wow, it's got a light on. Look at that. You'll get old one day too. This is the top land. This is where the top ring goes. This is the second land, and you guys that are engine builders, y'all know all this, and this is an accumulator groove right here that I'll show you. And then this is the second ring, which will be the oil scraper. And then this little teeny weeny little third land is not much of anything, and if you rotate it 90 degrees to the wrist pin bore, you can see that there's not much below the oil ring, because the oil ring doesn't really have a lot of stress on it, but it does scrape the oil off of the cylinder wall. This oil ring does, and it puts it back through these holes, these drain backs, where this oil drains back and goes to the sump. Another thing that happens when you're running a racing engine, and you guys have heard of a vacuum pump, also the vacuum can pull through these holes, come through and pull vacuum on the back of this oil ring. And if you put a little bit extra gap on the top rail, there's three-piece oil ring. It has a top rail and a bottom rail, and if we put a bigger end gap on the top rail, we can actually have some vacuum come through that top rail and get into this second ring area. And if you have a big gap on your second ring, it can pull some vacuum from there up and get into the bottom of this top ring, the compression ring, and pull some vacuum on it to keep it sealed on here. And that's one thing that gets left off when people talk about the vacuum pump, is they think that the vacuum pump is to pull the pressure of the piston going up and down out of the bottom of the cylinder, but in reality it's to put a negative pressure under the top ring to help seat it on the piston. Now, I'm going to move this piston out of the way and quit wobbling, and I'll try and draw a picture of what I'm talking about. Tell me if you guys can see this okay. I'm going to draw the top land, the top ring, the second land with the accumulator groove, the second ring, the third land, the oil ring, then the bottom land, and then where this is where the wrist pin goes. Y'all can see that okay? Kelby, Ed, Peter. Yeah, I do get a lot of old folks on here. Ed, I mean, thank God we lasted that long, right? Who'd have thought? But back to what I wanted to show you guys is I have a gas port drilled in this piston. I don't know if you guys saw it. And I've been over this before and showed you before. These gas ports, I really like these because they only are activated a very small portion of the time that the piston's going, the cylinder and the crankshaft is going around and around. It's only when the pressure in the combustion chamber and on the dome, that's only when that pressure is higher than everywhere else does this put any load on this ring. People say my gas ports were awesome, but my rings didn't last long. I'm gonna tell you, man, I'm gonna call BS on that. That's BS is that stands for before smart. I already tried it, and I don't want to argue about that. I just will disagree with you if you think gas ports hurt your rings. They don't. If they did, your rings were already wrong. Rings have different reasons. This top ring is for sealing this combustion pressure to keep it the pressure above this ring. That's what this top ring's for. I know that's noisy, ain't it? If any pressure gets by this top ring, it should be absorbed and built up in this expansion area, which is called the accumulator groove. This accumulates the pressure that may have gotten by the top ring. The second ring is an oil scraper. And of course, then we got the three-piece oil ring here. These are really got a lot of tension on them. This ring is used for cooling everything that this piston has in it. All the heat this piston has goes through this ring into the cylinder wall, and the cylinder wall is this rough looking thing. And when this ring is going up and down on this cylinder wall right here, and you're making lots of temperature in this piston, this heat goes through this ring into this cylinder wall. So you want to take the heat out of this piston and put it into this ring so that it goes in the cylinder wall, so that the water jacket or the fins on the cylinder will dissipate that heat. I've told you this before, and I'm sharing it again. Second ring scrapes the oil off so that this ring doesn't have to have 20 or 30 pounds of pressure on it to try and drag this down. We can put a less of a tension oil ring in it. And I'm not talking about a 9 or 8 or 7 pound smoker where the cylinder and the piston and the engine is burning oil. I'm talking about a nice ring that can control the oil. Like maybe I'm a more of a 12 to 15 pound guy. I don't like those people say you get more horsepower by putting a 6 pound oil ring in and you have to have a vacuum pump to control that. I'm sorry, that's not related. The vacuum coming in from the bottom through those grooves, coming up through the second groove and getting to the top piston ring is where we're getting extra sealing from. How's that for a complicated drawing? While I doodled around a little bit. Back to this piston, I'm going to try and draw something again one more time. I'll make it bigger so we can see it easier. Top land, top ring, second land, accumulator groove, second ring, third land. You with me? Here's the piston, top, dome, gas port, goes down halfway. This is the gas port. Can you all see this? Okay. When you take your engine apart, this is crappy drawing of the ring. When you take your engine apart, and this land is smoked, like it's burning, and this land is smoked. First of all, this ring land and this ring land, these parts of the piston right here, these are not supposed to touch the cylinder wall. But if you've got burn marks here and you got burn marks here, there's something wrong with your tune-up. There's something wrong with your clearance. But if you didn't burn up the skirt, but you got this too hot and you got this too hot, you've got an air-fuel ratio problem, you got an ignition timing problem, and this ring can't handle it. So there's several reasons why rings sizes and shapes matter. If you can get all the heat out of the piston with back in the day, what did we have? 5/16 rings. We had 16th. No, we didn't have 5/16 rings. I can't even write that down. I think we had 3/16 rings. Then we had a 16th top ring. Then we had an 043, and I just saw Lake and those boys put this on the. I saw a video of them putting this on YouTube. I think a 16th is .0625, and this 043. And then my favorite ring that we have today is, I love a .9 for almost every application. That means it's like 036. That's 0.9 of a millimeter. I don't know why they went from a 16th, and then down to 043, and then they went to a 1 millimeter. I'm going to move these over. Then they went to a 1 millimeter ring, which is .039. And then they went to a .9, which is that's a .9 of an 039 ring, which is 1 millimeter. 1 millimeter equals 03937. Is 1 millimeter equals .03937. 0.9 of 1 millimeter, that's a 9/10 of 1 millimeter, I think is a .036 ring. And they also have 032s. They have pro stock rings of a 028. They have 023s. The rings have gotten smaller and smaller and smaller over the years. And the reason is because if you're not having control of valve springs, you would, that's right. Alan just asked me, would it be an advantage to have it almost kissing? Yeah, I think so. I think that helps a lot. But you also want, you don't want it to when it gets a little. Well, you gotta have room for everything, Alan. You're exactly right. We're going to get a lot of questions off of this that I would love to share with you guys. But this 023 right here, this ring looks like an oil rail. If you've ever had a 3-piece oil ring in your hand, you can see the oil rail is really, really thin. And I'm going to try and draw an example of what these rings look like. The ones that used to come in the old 327 Chevy, I think was a 3/16, and then the 16th was a third that width. And then they came out with the 043, which was a little bit smaller than that. And then they came out with the 1 millimeter, and it was 4,000 smaller than that. Then the .9 is a tenth smaller than that. And then the oil rail is a teeny weeny little thin ring that's about 023. Now, when you have a top ring, it's 023 or 028, it will conform to the cylinder bores really, really great. But you've got to have a piston that can control that ring. This piston has a .9 top, a .9 second, and a 3 millimeter oil. Also, if you'll look, it has a really nice accumulator groove right here. Let me try and get this focused. Oh, look at that. Look at that. This is about 150 down from the top. This ring is .9 millimeters. This has an accumulator groove, and then this is another .9 second ring. And I'll tell you what the difference in the top ring and the second ring is, but I wanted to also share with you that when this land is dragging so hard, it's transferring material, it's too big, or the tune-up is wrong. And this land right here is definitely smaller than this one. And they get smaller in diameter as they go. What? No, the heat is way bigger here. It's a little less heat here, and it's a little less heat here. And by the time you get to the bottom of the piston skirt, the heat is about gone. Doesn't get real hot down here. Hopefully the rings transfer the heat into the cylinder wall. Now let's talk about these rings. Each one of these requires clearance to run. The old 3/16 rings, they had a lot of room where you could grab the ring and rattle it in the piston. And then the 16th, they got a little bit better, maybe 1 or 2 thou clearance. And then the 043s, we learned to make the ring land a lot closer to that. And then we learned on the .9s, now we're running almost a thou. And the guys that are running this ring, they're running less than a thou clearance between the piston and the ring. The ability for this ring to transfer heat into the cylinder wall is giant here. Less. And the thinner the ring you get, the less ability it has to transfer heat to the cylinder wall. So what we have to do is we have to decide where we want this ring. If it's in the fire too much, we might need a bigger ring, or we need to move this further down out of the fire. A couple things have done a really good job since all that was kind of discovered or invented, and that is the Piston Oilers. They call them squirters or whatever. And when we on the new Harleys, they have down by the base gasket, they have squirters that squirt oil up on the base on the bottom of the dome. The bottom of the dome, in order to cool this piston down so the ring doesn't have to do all the work. So a really great lower end wrist pin. Some people call them wrist pin squirters. Some people call them whatever, but it's not for the wrist pin, y'all. That oil squirter is to cool the crown of the piston down so that the ring doesn't have to do all that great work. So at the end of the day, we end up with less of a ring that we can control, or less of the mass of a ring. But if your goal is just to get the smallest ring you can in there, and you start burning up the piston around the ring, you know you got too much heat going on there, and it's going to need a tune. How do you tune that heat out of a ring? Well, the ignition timing is probably lit off too soon, so you're detonating, or you have too lean of a mixture where you got to have enough fuel in order to control the heat a little bit. And I want to, this is my opinion also. Listen, you guys, please understand my opinion, not yours. Opinion. Yeah, that's my opinion. This is what I think I know. And I'm not having an argument or really a contest about that. Everybody, there's some smart guys on here that I look up to that know more about this than I do. But this is a generalized view. If you guys ever ask questions about why is these rings different sizes, and you wouldn't believe how many measurements there are just for a guy like me. There's 32 measurements on this piston that I consider before I order them. Not the bore size, and not the compression ratio, and not the compression height, but there's 32 numbers, and that's not even half of them that the engineer that designs the piston has to put into the machine to make it. Also, I wanted to add, people say, well, do you have 12-to-1 pistons or 13-to-1 pistons or 14-to-1 pistons or 10-to-1 pistons? This piston right here don't care. This is a plus 20 cc dome. I'm going to write it down. This piston has a plus 20 cc dome. What that means is these pockets are deep. Not deep as everybody else's, but these are valve pockets are deep. Well, cc's go in there. There might be 10 cc's fill these pockets up. What plus 20 cc's means is that we fill the pockets up to 0, and then we put 20 more cc's on top of that. No, that's not right. That is not right. I'm going to say it better this time. This piston right here is 20 cc's positive. If I made a flat top right here, this piston could be minus 5 cc's because these pockets fill up. You have to fill them in order to get to a flat top. A flat top has negative cc's. A pop-up has positive cc's. A dish top has valve pockets and a dish top, which makes this could go down to negative 20 cc's. And this is not what the compression ratio is. This is not what the compression ratio is because there's way more to it. It's the thickness of the head gasket, how far away the head is, how far away the combustion chamber is, how big the combustion chamber is. All those matter. This 20 cc plus dome could be 10-to-1 if we built the head the way it needed to be to fit. This plus 20 cc dome could be 15-to-1 if we made the chamber small enough to accept that. This piston does not dictate the compression ratio. It is a piece of the puzzle. That's like saying that a tire has a wheel built into it. The tire and the wheel make the whole piece that the car rolls on, but not the tire alone, not the wheel alone. This piston is an element of the compression ratio, not the deciding factor. Now, if you've got a stock head that has, what is a stock and have? Like 85 cc's on a Milwaukee 8. 85 cc's with a plus 20 dome, this is high compression. Before I get away from the rings, I wanted to share with you that the rings have to seal the combustion stroke. They have to seal the power stroke. They have to seal a little bit on the intake stroke. And that's really what they're for. That's only 180 degrees, maybe 100 degrees out of 720 degrees rotation. So the top ring, if the gas ports are too big for your mind, you have to understand they're only turned on for 90 degrees of 720. Remember guys, we got 180 degrees of intake. We got 180 degrees of compression. We have 180 degrees of power, and we have 180 degrees of exhaust stroke. That's 720 degrees. 720 degrees of rotation. The gas ports are only active when the pressure is big, and that's less than 90 degrees. So if you think gas ports are wrecking your top rings, you don't understand that there's a lot more going on other than how much pressure is coming through these little baby holes. Response time is important on that. If you got little teeny weeny little baby gas ports, it takes a while for that combustion pressure to travel through there. And if you got really big ones, and if your ring's way down in the hole, you got a lot of response time, because think about it, a short pipe, this is a pipe. This is a teeny weeny little pipe for the compression to come through and get behind that ring and blow it out in the cylinder wall. And it only blows it out for whenever the pressure's high. If you ever turn your engine over by hand, and this reminds me of a friend of mine that was just on the internet talking about it the other day, put his finger in the spark plug hole, and he turned his engine over by hand, and it was blowing on his finger sometime out of the rotation, and it was sucking on his finger sometimes, and sometimes there was nothing going on. Well, when it's blowing on your finger, that's the only time these little ports are active. The rest of the time, there's nothing going on there that we need to worry about to affect us. So I'm a gas port guy. I love running the gas ports, and I will be probably forever till proven otherwise. All right. Last thing, I want to talk about why this is cut away and why this is not cut away. Good news on our piston design is this would be the front of the rear piston, where the front this is the front of the rear piston, where the front cylinder has to come by here when this piston goes up and down. But the major thrust is on the back of the rear piston, and the major thrust is on the back of the front piston. So our front piston has no notch, and our rear piston is the only piston that has a notch on the Harley V-twins. If I drew a picture of this for you, you would say, oh, that's a V-twin. What if it looked like this? Oh, that's a V8, V4, V6, V12, V10. The only thing that's different is the V-twin, like the Harleys and the motorcycle twin engines, is this is all open, whereas on the V8, V10, V4, V6, you have a camshaft here and a crankshaft here, and on our little Harleys we have the camshaft here. And of course the lifters and the push rods go up to the top, which is another story another day. But I wanted to tell you, this crankshaft on all of my named, a V8, a V10, a V-twin, a single, so let's say the crankshaft's going clockwise. And you want to realize that this cylinder is going to get oil it's going to sling off the crankshaft. Some of it's going to go in here, some of it's going to go in here. And if you have that kind of windage going on where the oil wrapped around the crankshaft, it goes up in this cylinder, goes past this cylinder, or it goes past this cylinder, it slings up in this cylinder. The V8s, all of them have it. If you're looking at a V8, this is the driver's side, and this is the passenger side. If you're looking at a Harley, this is the front cylinder, and this is the rear cylinder. This is a V10, this is the driver's side, and this is the passenger side. And I just noticed I ran out of time because it doesn't matter, but this is another time I got to finish this story. I just tried not to keep it so long. I've been fortunate to keep some good folks signed up on here. I wanted to tell you guys that the feedback, I got several guys this week. One guy told me that it really helped him understand what's going on. Another guy told me that he has so many more questions now. I won't be able to answer all your questions in my lifetime about engines because I'm still learning at maximum speed, you guys. I am learning at maximum speed. The more I teach and the more I talk about this stuff, the more I learn. And I would love sharing this with you more. Please give me some feedback. Send me back a message on my Facebook page or my Instagram page or YouTube. It's called Star Racing GA is our YouTube page. I think it's like one word, Star Racing GA. And Jackie takes this recording that I'm doing live now, and she will inject it into the YouTube page, and it will be called Tech Talk number 121. This one's over. I'm out of time. Thank y'all so much. Please share your thoughts, your ideas. And I'm not going to claim to be the only one that's right about this stuff. I would love to hear your opinion of what I said that might be wrong because I'm moving so fast that a lot of times I say something I really didn't. No, but I'm landing the airplane now. I've been circling it for a while. Thank y'all. Thank you so much for watching. Please write back and let me know what you hear, what you see, and what you think. May God bless y'all. Oh, happy Thanksgiving. And thank you for all the congratulatory messages on our 42th anniversary for Star Racing. May God bless. Bye.